height of the water with respect to the time was actually increasing.
And that's correct. Jim's group, I heard you describe that same pattern just a little bit differently. Do you mind saying a sentence about how the average rates of change?
I don't remember what we said. We talked about magnitude. You want me to use that phrase?
Let's go for that, yeah, let's do that.
We said that in magnitude, the change of height was decreasing.
Uh-huh. And could someone describe what's happening in the bathtub?
The water is, the height of the water is getting less and less as time goes on.
And the rate
It's
is
decreasing by smaller amounts.
because it's like it goes out faster when there's more water, and then it slows down as there's less water in the tub.
So as counterintuitive as it sounds, we would say the water was decreasing at an increasing rate.
Yes.
I think that's what I was, okay.
Wait a minute, what'd you just say?
The water was decreasing at an increasing rate.
Wait a
The rate of
minute.
change was increasing.
You told me the water was decreasing.
But
And the first group told me that
The rate was
The
increasing.
rate was increasing.
at an increasing rate, it's getting closer and closer to zero.
So even though Carlos said smaller amounts were actually leaving the tub, maybe.
Because I think that's not what I said.
Oh, you didn't? I thought somebody said that smaller amounts were leaving the tub because there's less.
I said it was going faster when there was more water in the tub than when there's less water in the tub.
And is that right?
No, actually, that's backwards.
Well, I don't know. I'm still trying to figure it out too.
The water, what I heard Jim say, the water is decreasing at an increasing rate.
So does that mean it's going faster?
The more water
Closer to
is-
zero?
yes.
The less water you have?
Yes, because the sides of the tub are sloping.
Well, wait,
No,
don't.
it doesn't mean that because the rates
So
of
the
change
height-
are all negative. As time is progressing, as time increases, the rates of change are the change in age is negative.
Mhm.
So when you're saying that it's decreasing at an increasing rate, you're meaning that the rates are increasing to zero.
So that it is getting slower.
So yes, the magnitude of the change is decreasing.
Okay.
That's where you use the word absolutely.
Okay. All right. There we go. I'm with it now. I'm there.
So what Carlos said was correct, and I was misinterpreting what Jim said. Right. So it is moving out faster when there's more water in the tub.
Yes. It's moving out faster when there's more water in the tub, but because all those are negative, because it's decreasing out of the tub, then
It's a faster rate, but not in magnitude.
Not in
It's just
right.
because
It's fast, because you can tell by the graph, it's faster there, and then it kind of levels off. So the water, it's not coming out as fast at the tail end. But it's freaky.
I think it would be useful to look at the same pattern again visually. And since the graph came from Zach's group, would someone in Zach's group talk about C and your graph?
C and the graph. Well, it took us a while to figure out what to do with that, but we eventually decided we could look strictly at that last column of the table. And we would only do it in a rather loose way, since our changes in time are not equal. We could not really directly compare. But if we looked at those average rates of change, we can see that they are in fact increasing to zero. So we said because, even though we can't really compare because we don't have equal changes in time, those values are increasing towards zero, which is the hallmark of a concave graph.
Would you feel comfortable coming up here and showing how those increases went towards zero? Or the decreases went towards zero?
Well, let's look
I
at
think just as a fellow student, I'm kind of interpreting your question and thinking, does it have something to do with the horizontal and vertical distances that you've drawn on there?
Yeah, it does.
Yeah. So not the curve itself, but Could you explain
Getting
those
closer to
horizontally?
zero.
I don't know what's getting close. I don't know what
the tangent line.
Yeah.
The average rate of
The slope of the
change
tangent
is
line.
represented by the slope of the line, which
Yeah.
is,
But we're not talking about tangent lines.
Right.
well, I know.
Could you
It's
Yeah.
hard to do this in
So
pre-calculus.
this is critical, I think, and this is
Yeah.
critical to Marilyn's approach. Could somebody from your group go up and,
The slope of the line.
yeah,
And it was tricky because the changes in input were not equal.
yeah.
And I think I should have assigned number one first.
Oh, well,
But this is
that's
So-
okay.
great.
so
This
what
is
we
great.
did-
It's okay.
In
So he's
order-
gonna get around it.
Now, this is kind of the cart leading the horse because it was asking us to decide whether this graph is concave up or not. We have assumed that it is here. So we really had to use the table to justify, but let's just look at this picture and say, this is a concave up graph. Then what we did was we actually looked at equal changes in time moving across. And we drew lines over to the graph to indicate what the change in height would be for this equal change in time. So we looked, say, at these 2 points here. You draw up. You could draw a line across. This is where this is the actual height at 2. Go over to this point, measure up. There's the actual height at whatever that is, 3. So you can see what delta H is. It's going to be, in magnitude, it's the length of that segment. Right? It's negative actually because it's decreased, but it's going to be the length of that segment. So then we did it again. That was going from here to here. So if you go from here to here now, measure up, and we missed the point a little bit here. We go to this point, and now consider the change in height from 3 to 4.
We did 3 to 5.
Is that what that is? Well, this is 3 now.
Oh, maybe it was 2.5 and then 2.5 to 5.
Well, let's just do it from, let's keep equal time.
Yeah.
Do you want a pen? And
I
you
was
could draw
using- I
on
was
it.
using-
Draw on you can
Draw
draw
on
on
a piece of
your,
paper.
on your piece of
Or we
paper.
could pull up
On the
the,
Elmo.
Yeah, but,
Do you want a pen to draw on your Elmo?
It just,
so if we look at, say, from 2 to 3. This is going to look rather crude.
I think that's been working for us so far.
Being crude is working for us.
I think it's worked for us so far.
So if we measure change in height, there it is. Let's call it delta H1. So that's one change in height. Now if we go the same time interval, we move one time unit over 3 to 4. Here's the actual height. So if we want to know what the change in height is this time, there's the change in height. Delta H2, and it's small. In magnitude, it's smaller. Now these are all negative, so what's happening is these changes are increasing to 0. Because in magnitude, they're shrinking. They're getting
Right.
smaller and smaller as you move along. So we use, that's kind of the hallmark visually of how to see a concave up graph. You look at equal changes on your horizontal axis producing decreasing changes on the vertical axis.
Okay,
Decreasing in magnitude.
right, yeah. Okay.
oh, I appreciate that, Jim. I think that brought some clarity.
Yes.
How would that work on the right side?